welcome to the third episode of Characterization with Shanli. In the previous episode, we explored the configuration of the D8 Advanced X-Ray Diffractometer by Bruker Company and performed X-ray diffraction (XRD) analysis on a stainless steel powder sample. Now, in episodes 3 and 4, we will conduct a comprehensive evaluation for the test results by using advanced tools and techniques like ICDD, PDF cards, OriginLab, Profex, Qualx2, and Match programs. So these detailed approaches will provide deeper insights and more accurate understanding of our samples and their properties. So stay connected by subscribing our YouTube channel and don't forget to follow our Instagram page to stay updated and for more and exclusive content. First, I would like to present the graphical analysis results of the stainless steel powder sample, which we took it in our second episode. So let's open the file. As you might remember, in the second episode, I discussed some of the most innovative technologies introduced by Bruker Company in the latest version of the XET detector. One crucial advantage we highlighted was its ability to efficiently filter K-beta radiations. So as you can clearly see from the graph displayed on my screen, the XET detector eliminates K-beta radiation almost entirely. So let me make the screen smaller and pick my pen, manage its color and thickness. Okay, we are ready now. You can clearly see the peak, which is related to the K-beta radiation, but you can find this peak in the black diagram. So this proves that this detector totally removed this peak, which is related to the K-beta, with only about a 20% loss in intensity, even when operating under high resolution and high count rate conditions. So, I want to remind you what was a K-beta filtering refers to. So, let me briefly remind it to you. K-beta filtering refers to the process of removing unwanted K-beta radiation while maintaining the intensity of the desired K-alpha radiation. This filtering is essential for conducting precise and reliable diffraction analysis. So let me clean this purple line. Okay. The second advantage we highlighted in the episode 2, which is clearly also visible when comparing these two red graph and the black graph, is the smoother appearance of the black graph. This improvement is entirely due to the XET detector's excellent and complete fluorescence filtering capability for iron. So, the black diagram, as you can see, is totally smooth. So, I want to continue by discussing the standard PDF cards. So, let's close this file and open the ICDD PDF card, which is related to our stainless steel powder sample. Okay, let's increase its magnification, pick my pen, and organize its color and thickness. Okay, we are ready now. So the PDF card, which is displayed on my screen, provides more information about the three different crystalline phases. The first one is iron, the second one is nickel, and the third one is copper. Now, I want to explore the properties of each element's phase in much detailed way. So let's start with the first one. The first one is iron with the formula of Fe. So you can see the ID of this PDF card, which is 04 minus 014 minus 0171. So if you are in the process of writing an article and you want to give a reference for your materials which you have done some research on it, and you can use this PDF IDs, but of course you should add the phrase of ICDD before these ID numbers. So ICDD, and after ICDD, let me change its place. You should write O4 minus O14 minus 7171, and you can give uh, this PDF card as a reference to your material in this shape, in this style. So let's explore the details of this PDF card. So also I want to increase its magnification. I think it would be much better, easy to you. So here we have a lattice which related to the crystal system. This show that our iron's crystal system is cubic. Now we have a space group which is 1m minus 3m. Here we have lattice parameter which is 2.86 angstrom. Here is the molecular weight value 55.85 gram per molar, and here we have density. So here we have some columns which I want to give you some more information about this. D, as you know, and also I explained these factors in our first episode in much detail with, but I want to repeat it again. Here D is the spacing distance between our atomic planes, and we have here two theta peak values. Here is H, K, L, which are our Miller indices. But here we have I fix. What is iFix? In XRD analysis, iFix in a PDF card are referred to the intensity normalization, or maybe scaling value also we can mention, to present the fixed relative intensity of specific diffraction peaks. The iFix value helps you to standardize and identify the most intense peak in the diffraction pattern of your sample. Or maybe you can compare this across different materials, or you can compare the different phases together. So we have iFix also. So here you can see the radiation. The radiation which is used in this analysis is Cu, copper. But of course, we have some other different radiation materials like copper, cobalt, iron. The wavelength which is related to our copper K alpha radiation is 1.54. So the other PDF card, which starts again, if you want to mention this PDF card as your reference to your article, you should add ICDD. So then you can write the PDF ID 010 61 48. So the idea of your PDF card is this. Let me highlight it. So our second material, as you know, is nickel. Our lattice crystal system is cubic. We have again space group here, lattice parameter, molecular weight, density again. So we again have D 2 theta I fix HKL Miller in these values. So again, as we use the Cu radiation K alpha in the previous element, again we use it in this element detection, which its wavelength is 1.54. The last PDF card is related to our Cu copper element. Again, we have all these mentioned values here in our PDF card. Again, I have here the ID of our PDF card. So what I want to mention here is, okay, let me decrease the magnification. Here you can see this PDF card give different colors to each elements, like red is related to iron, blue is related to nickel, and green is related to copper. So here in our diagram, you can see different peaks here, these ones. As you can see, the primary and most which has the most higher intensity is related to iron. And as you know, stainless steel samples always are primarily made of iron. So our highest piece and most stronger one is related to iron. So our strongest piece, peak is iron, which is shown with the red color. And here we have different little peaks. Let me increase the magnification, which is show with green color. Green color is related to copper, so we can see this peak show the composition which include copper element. Here we have the nickel. I think blue one is related to nickel exactly. So again, we have a iron peak here, which is not as strong as the first one. In today's informative break, I want to share the fascinating history of XRD PDF cards with you, our dear audiences. Back into the 1940s, the X-ray diffraction XRD analysis was advancing rapidly, but actually identifying the materials was really challenged because there was no reference databases at that time. So this led to the formation of the Joint Committee on Powder Diffraction Standards, JCPDS, where scientists like Howard Brooksby and William Parrish created the first catalog of the crystalline material, which physically was handwritten and type index cards. So by the time these index cards evolved to transform to fully digital ICDD PDF cards, which boosting over 1 million database and entries, even materials like meteorites, a truly crystal fingerprint library for the scientists. After a historical informative break, I'm here and I want to show you how you can draw the XRD diagram by using OriginLab program. As you know, you can directly use the XRD diagrams which are in the PDF cards in your proposals, posters, theses and articles. So you need to redraw them in different programs like OriginLab or Excel. So I personally prefer OriginLab because of its different style. So I usually use OriginLab for drawing my XRD diagrams. Now I want to show you how we can draw the diagram by using the OriginLab program. So here we have the raw data. Let me remove this file one. Here we have the raw data of our XRD analysis results. So I just want to open one of them. Here, my PC opened the raw data in the notepad format. My PC's setup language is English, but if you use different language like Turkish and you want to draw this diagram in the Turkish language setup, you need to change the dots to commas or commas to the dots. So it's really easier to use Excel program. So you need to copy paste your datas to Excel program. First of all, I select my all datas here. Control C. I open the Excel program and paste my datas here. Okay. Now I just finished my work with this notepad. I can close it. Now I need to go to Origin Lab program. You can download the education learning editation for students. But you need to reactivate it every 6 months. So you can reactivate it by sending email to the official website of the Origin Lab. They're gonna send you the license number, and you can activate your account again by using that license number. So here I'm gonna copy paste my data from Excel to Origin Lab. As you can see, I have two columns here. One of them is related to my X values and the other one is related to my Y values. I paste my data here. Okay. As you know, X my two theta values. And Y column is my intensity. Then I select these two columns, and you can also choose plot, or you can choose this option in the bottom left, then click on it. Now you have your XRD diagram. You can change its style. For example, you can change the range of your 2 theta by double clicking on the data and click to scale. I want to be from 20 to 80 degrees. I don't want to have data here. I just delete them. So then you can design it by your personal style. For example, I just do this intensity. We have intensity here. We have 2 theta degree here. I want to delete these dashes. And also you can increase the size of these scales, or you can decrease their size. Also, you can change the font of your writings. I want to set up to the Time New Roman. Also, I want to bold it. Again, I want to change its format to Times New Roman and make it bold. Now, it's our stainless steel sample. It doesn't need to write, but you can write your sample's name, stainless steel. Okay. I just want to remove the box around the text. You can select the frame to be on or off, and you can change the color of your diagram by double clicking on it and change, for example, let's make it pink, my favorite color, and apply it. And it's finished. And also you can make them bold, increase line thickness or decrease line thickness. As you can see, now I'm increasing the line thickness. Also, you can select the line thickness from here. For example, I usually use 1.5. So let decrease the line thickness of the text. Now, as we applied for all the other texts, we can also change the font of the scaling values. We can click on them and change any font that we want. For example, I always use Time New Roman, so and I want to make it bold. Okay. Now I want to open the ICDD file of our PDF card. Now I open my ICDD PDF card. So it's exactly as the same as the diagram I draw in OriginLab program. As also you can see from my screen. Now I want to name these pics. For example, this pic is related to iron because it's drawn with the red column. So it's about, let's find it from origin because it's really easy to find because you just point the pic with your mouse. So it's our 2 theta value is 44.6. 44.6. Now we're gonna select 44.6 and find it from our PDF card for iron. 44.6. So yes, we have here. Let's make it much precise. We can just focus on the peak. So it's about 44.7. Exactly, it's 44.7. So we're gonna find the 44.7 on the PDF card. So all of these are 44.7. Miller indices here like 110, 1 minus 10, 101. I choose 110. So you can add 110 on the top of this pick. You should select the text tool from here and you can write 110. So you can just organize its placement. Okay. Make it bold. Okay, place on top of the pic. Now let's name these pics also. So let's find the precise amount of the 2 theta for this peak. 65.04. So 65.08. It's approximately same. So we can use these values. Also these three values. We can choose 200. So again, select the toolbox and write 200 inside the parentheses and make them bold. Okay. And our diagram is ready. So for using this diagram in different articles, posters, or maybe your thesis, you should export this diagram. So you should right click on the graph and select the export graph. Write the file name, select the file path. So I just want to select my right file path, desktop. You can preview it or you can just download it without previewing. So I just going to download it without any preview. So click the OK, and also you can choose the image type from here. I choose PNG. So OK. Our graph is ready. Thank you very much for staying with us till the end of episode 3. In the next episode, we're gonna present you the detailed tutorial of the Profix, Match, and Qualix 2 programs. So stay tuned and take care of yourself. See you soon.